Assalamualaikum and salam sejahtera. We are from Group 8. We will be presenting about the HAZIQ cross method. But before that, I would like to introduce our fellow members. Okay then, I will start with the introduction. Water distribution system. A hydraulic infrastructure that includes pipes, valves, pumps, tanks and reservoir among several other components. This infrastructure helps in the transportation of water from the source to the final user. Water distribution system must be capable of assisting abnormal conditions such as pipe breakage, pipe, valve and control system mechanical failure, power outage and inaccurate demand projections. The HAZIQ cross technique. The method was first published in November 1936 by its namesake HAZIQ Cross, a structural engineering professor at the University of Illinois at Urbana-Champaign. An iterative approach for calculating flow in pipe network system with known inputs and outputs but unknown flow within the network. Due to non-linear relationship between head loss and flow, solving complex pipe system for distribution was extremely challenging before the method was introduced. For the problem statement, we need to analyze the discharge queue for every pipe of water supply system that is located in town A. Then, we need to know how to use the HAZIQ cross method to compute the discharge of every pipe in town A that has a water supply. Finally, we must consider how and where the HAZIQ cross approach should be used to this assignment. There are three objectives. Objective 1 is to figure out the discharge of every pipe of water supply, find the value of the discharge at every pipe at the water supplies, and figure using the HAZIQ cross method with the equation.
Hi, my name is SYUKRI and I'll present about the methodology of our project. So in methodology, I'll present about the procedure to conduct the HAZIQ cross method. So for the first step, we need to assume flow distribution. We need to assume any flow amount in pipe as long as the quantity and direction preserve flow continuity. And then we need to calculate the head loss, H equal to RQ to the power of N. And then we need to calculate total head loss around each loop by using the formula summation of H equal to summation of RQN. And then we need to calculate R by using the formula R equal to NRQ to the power of N minus 1. And then we need to calculate total around each loop by using the formula summation of R equal to summation of NRQ to the power of N minus 1. And then we need to calculate the flow direction by using the formula change of Q equal to summation of H divided by summation of R. And then we need to correct the flow by using the change of Q. We need to calculate the reverse flow. And then for the last step, we need to repeat from step 2 until change of Q is small enough for our application. So that's all from me. Thank you.
Assalamualaikum, my name is Muhammad FAHMI bin MUNI and now I will be presenting about calculation. Okay, for the pink table is value for inlet and outlet pipe and friction factor for all pipe network. Hence, the green box is formula that we use to find value for HF, K and delta Q. Next, for the blue box is the formula we use to calculate Q for shared pipe and unshared pipe. Next, below is the figure for our loop and the table beside is value that we got for loop 4 using the formula stated before. The K value calculation will be shown in the next slide. So this is the calculation to find K for loop 4. By inserting value into the formula, we can get the K value for pipe 10, 11, 12 and 13 as you can see in the slide. For the next slide, it shows HF value that we got for FJ, FH, HI and IJ in loop 4 trial 1 by using the stated formula. And the table beside is the value that needed to substitute in the formula. N modulus KQ power of N minus 1 for loop 4 trial 1 for pipe FJ, FH, HI and IJ, and the value is 20.760, 36.024, 6.814 and 197.828 respectively. That's all from me. Thank you.
Assalamualaikum. My name is NAQIUDDIN bin BAKAR, and now I will continue explain about the calculation. From the FAHMI told before the value, we must put down into the table and find the theta Q1, and the theta Q1 value is negative 0.0083. Next, for trial 2, the pipe and K value is the same, but the Q value is a little bit different and we must find the new Q value. By using the formula that given, the new Q for the pipe is negative 0.018, 0.01, 0.018 and 0.012, and then we can find the theta Q2. and the answer is negative 0.0028, but the answer is not met the requirement from the equation, so we must go to the trial 3. Trial 3 is also same value, but the Q is also new, which is 0.01, 0.021, 0.01, 0.015, and 0.009, and the theta Q3 is negative 0.00073, and that met the requirement from the question. That's all from me. Thank you.
They have two advantages that we get from using a Hardy cross method. For the first point is it is simple methodology to solve the problem. The Hardy cross method is useful because it relies on only simple mathematical, circumventing the need to solve a system of equation. Without a Hardy cross method, engineer would have to solve complex system of equation with variable exponent that can easily be solved by hand. Now, something that we get from this method is self-correcting. The Hardy cross method literally correct for the mistake in the initial guess used to solve the problem. Subsequent mistakes in calculation are also literally corrected. If the method is followed correctly, the proper flow in each pipe can still be found if small mathematical errors are consistently made in the process. As long as the last few iterations are done with attention to detail, the solution will still be correct. In fact, it is possible to intentionally leave off decimal in the early iteration of the method to run the calculation faster. From the calculation, the Hardy cross method is easy to use because the outflow for each pipe loop 3, 4, 5, and 6 have been used in the equation. The flow rate in the pipe join at a junction, and any external flow must satisfy the continuity requirement for each junction. In other words, a better intentional prediction results in fewer iterations to find the solution with a flow Q value. Additional loop makes system less tolerant of inaccurate prediction since they either need many more iteration or diverge rather than covers in some cases. Regardless matter whether the application is on fluid or electricity, the technique mentioned above can be used. As a result, the Hardy cross method generally needs additional round of adjustment when several loops are involved.
Hi, my name is SYUKRI, and I will conclude our presentation. In the real life, there are many problems related to water, such as problems related to distribution of water and even the design of the water supply system in an area. All of these problems can be solved by using fluid mechanics calculations, for example, Hardy cross method, Darcy-Weisbach equation, Reynolds number, Hagen-Poiseuille equation, and many more solutions. For problems that are related to the pipe network, it is proof that Hardy cross method can be used to solve the problem related to it, especially in doing the analysis of discharge for the water supply system of an area. Civil engineers may use water distribution system modeling to address a variety of critical issues concerning municipal and commercial water delivery system. So, it is proof that fluid mechanics is also an important course for future engineers to study before they step into the realm of work. So, that's all from our group. Thank you.